So instead of x minus 2 less than del, I'll have. Yeah, right. Okay, so that's the point, right? So I'm allowed not to. Okay? Okay. Say this happens, and we have this, we have this. So since x doesn't equal 2, okay? So you just have to make a small modification, right? In the reasoning. Just to always say, well, I'm not even looking at what happens when x equals 2. Okay. All right, well, then we have now, so now, you see, there is always this distinction as to whether we should look at what happens when x is a, or whether we shouldn't have to look at what happens when x is a, right? All right. So, if we're doing then x goes to 2 of x squared equals 4, we the first column is this, right? We're doing then x squared. Okay, that's okay to let x equal 2, right? Over here, it's not okay. Not when you're taking the limit, right? You're letting x go to 2. You don't want to let it get to 2. Okay. So what? Does anybody know the difference in the terminology that we use to distinguish this type of function from that type of function? Which one? This one's continuous, right? So, all right.
Professor?
Yeah.
You're saying that it's not okay for x to equal 2 because of the definition of g of x up there, right? Where, okay.
In other words, it's not okay to let, when you take the limit, when you let x get closer and closer to 2, it's not okay to let x equal 2. Is that one, right?
Right.
Yeah.
So should we always state that x can't equal, in this case it's 2, just to be safe? Or
Yeah, I mean, okay, well, that's where we're going. Okay, now, okay. All right, so we say f is continuous at a if, so what's the definition?
the limit as x approaches a.
Let's go to a of is equal to
F of a.
f of a, right? Okay, good. So that's true here, right? In other words, you get the right answer by plugging in a. So here, if you plug in, this function is continuous, you let x equal 2, you get the right answer. This function is not continuous, you let x equal 2, you get the wrong answer, right? You get the freedom. So now, this definition is, I'm sure you've been taught in calculus classes, has several different, it subsumes several different things, right? Just by breaking this, I'm making several implicit statements. First of all, the limit must exist, right? And I don't want to say all that explicitly, but I can't even write this statement down unless the limit must. So this must exist f of a must exist. Let me get into that in a minute. And then we also have equals, right? So three different things, right? There's three different things going on. Now I haven't even told you that. Now the issue, there's also an issue as to whether f of a exists. Okay, now let's just take another function. Suppose this function is just it's undefined at x equals 2. So there. Right? Now, still the limit equals 4? Or we have a problem? The limit still equals 4, right? It doesn't have to be defined at 2. In other words, it doesn't matter. It doesn't matter at all what happens when you're at the point A, right? In this definition. It doesn't have to be defined. But okay, now I'm implicitly, again, I'm saying every word here, where must it be defined? For this definition to make any sense at all, I'm just going to say this once and probably never again. The function doesn't have to be defined at A, right? At all. But for the definition to make sense, it has to be defined where? Right, and near A it has to be defined, right? So it has to be defined in a whole open interval containing A but maybe not at A, right? So it has to be defined somewhere, and it doesn't have to be defined for all real numbers, except for A. It just has to be defined on a little open interval. But I don't care because it's defined at A, right? Okay, so that should clarify this, right? So the definition of continuous is the limit must exist, the value must exist, and they have to be the same, right? Okay. Now, so let's then write our first general proposition here. It spares some more space, maybe. All right, let's just write it here. Okay. Proposition. Say f is continuous at A. Right. Okay, now let's just take this. How can I modify this definition here of limit? If it's continuous, I can say a little more, right?